People have been proclaiming the death of passwords for like a decade. This article is from 2013. And it's fair, right? Even though they're everywhere, passwords also kind of suck. They're often too easy to guess, or they're reused around the web. And when there's a password breach or a database breach at a company, this can be a really big problem. And so far, our ways of addressing this, things like password managers or even optional 2FA, while these things are really helpful, they don't fully solve the problem. And this is where WebAuthn or web authentication comes in. It's part of the FIDO2 spec to eliminate passwords and make account security more secure while also keeping things user-friendly. And that's what I'm going to be talking about today. My name is Kelley Robinson. I have been working at Twilio for about 3.5 years. I specifically support Twilio's account security products for things like user verification and phone intelligence. The team has evolved a lot since we acquired Authy over 6 years ago now. Authy is our free consumer application for 2FA. But I also spend a good chunk of my time educating developers about security and especially things about authentication. Some of the things that I'm going to talk about today include what WebAuthn is and how it works, looking at where WebAuthn really shines, and also some of the obstacles that we're going to see in the next few years until we see a lot of implementation of this spec, and finally, how you can get started with WebAuthn. But let's cover the basics first. So WebAuthn is short for web authentication. They're the same thing. And with this spec, instead of a password, an authenticator uses public key cryptography to create a key pair. So there's going to be a private key and a public key. That's known as a credential. And this is going to be specific and scoped to an individual website. WebAuthn is a specification, and so it's not just some proprietary solution, it's something that we hope to be standardized around the web. There's browser APIs for this, so you have to be conformant to a browser API. But one of the most important and exciting parts of the spec is that these credentials are scoped to specific sites, and this effectively eliminates phishing. WebAuthn also relies on authenticators to create strong credentials, and there are two categories of authenticator, and this is important, and this is how people and end users are actually going to be able to replace passwords, is they need to have one of these two types of authenticator. This could include a platform authenticator. This is going to be something like Apple's Touch ID, Face ID, Windows Hello, something that's built into a device that we already have and carry around with us, most likely a phone or computer. And the other category is roaming authenticators. This could be something like a YubiKey or Google's Titan key. This is going to be a separate physical entity that you're going to carry around. You know, I have a YubiKey here that I can use for something like that. There are also a lot of acronyms involved here, so I do want to clarify some of them. One of the things that we start with is just the idea of what FIDO is. I mentioned earlier that WebAuthn is part of the FIDO2 spec, but FIDO itself is the FIDO Alliance. This stands for Fast Identity Online. They're a group of people that get together and put together these types of specifications that help reduce the world's over-reliance on passwords. So that's their whole mission. And when it comes to some other terminology, just to clarify some of these, you might hear me talk about a relying party or hear the acronym RP. That's the spec's way of referring to a business or an organization. And so this is going to be the person that's implementing the authentication. So if you're like Domino's Pizza, adding authentication to your website so that people can order pizzas more seamlessly, the relying party in that case would be Domino's. The next one that I want to call out is CTAP. This is the client to authenticator protocol. So this is how the authenticator, like a YubiKey or even a platform authenticator, would talk to the browser. And there are two evolutions of CTAP. The first evolution, CTAP 1, is the same thing as U2F. And U2F is a universal second factor. As the name implies, this spec was designed to be used in 2FA in addition to passwords or another factor, not just as a password replacement. And so the evolution of that, CTAP 2, is what's being used with WebAuthn to make FIDO2. And so CTAP 2 is the evolution that allows you to use an authenticator as both the first and second factor. So you essentially have 2FA without having to use a different type of device. And this is because you can combine biometric authentication with the device itself. So you have a possession factor and an inherence factor in one. Many authenticators are backwards compatible with CTAP1, so they would also be U2F compliant, but that's going to depend on the device itself. All right, let's talk a little bit about how WebAuthn works. For a registration, the important things to note are that a server is going to send details about the website, and that's to help scope the authentication credential in order to only work with that website, to create that scoped credential. And then after the authenticator creates a key pair, only the public key gets sent back to the server. And let's take a look at a quick demo to see how that works. I'm over on WebAuthn.io, which is an example website that Duo Security built. It's a good thing to play around with. You can go to this website if you want to check it out too, but I can quickly show you how the registration works. So they tie this to a username. You have to have some kind of identity that you can authenticate against. I'm not going to specify an attestation, and the authenticator type for this example, let's go with platform. Cross-platform is their way of saying roaming authenticator. So it will say, do you want to use Touch ID with WebAuthn? This is using the browser API to detect what type of authenticator I have. Since I have a MacBook for my work computer, it notices that I have Touch ID on the device. I can go ahead and click continue. It's going to say use password, so it's going to Touch ID or enter the password. This is interesting because it's automatically providing me with a fallback option here. But I'm going to go ahead and touch the device. You didn't even see me doing that, but you can believe that I did. And so it's saying, cool, that I can now, I've registered the device and I can try logging in, and we'll show that in just a minute. You can't leak credentials with WebAuthn in the same way that you could with a password or even a TOTP secret. And that's because the private key and any biometric data that's associated with the authenticator never actually leave the device. The authenticator only validates the biometric data, matches what it has stored before it would sign a credential or create a new one. And the public key and attestation are sent to the server, but even if the server gets hacked, those are pretty useless without the private key. I wanted to talk a little bit about attestation because it's referenced a lot when you're reading about WebAuthn, but it's actually not required. Yubico's developer docs even actively discourage collecting attestation information unless you have a specific need for it, and that would be setting it to something other than none. And that's because it's more work for the relying party, and it could limit the types of authenticators that your customers could use. I spoke to Cloudflare about their implementation, and they did set their attestation level to none. So there are production implementations that are following this device. And I think it's one of those general security principles of if you don't need the information, maybe you don't need to collect it. I do know that there's certain government agencies that have specific authenticators that they want to put on an allow list. So this is what helps ensure that the approved authenticators are what's being used. But unless you're a government agency with one of those specific needs, you might not need to collect this information. So like I mentioned, the default is none. No attestation info will be collected or sent over. Indirect and direct attestation will give the relying party an attestation certificate, but that can't contain any PII. It can contain information maybe about the device type, but it's not going to contain any information about the end user. And if you do happen to have a closed deployment, you can set this to enterprise, and that would be a way that you could have PII sent over in that information. But that's only going to be if you're using this within your company or something like that. So once a credential has been created, the ongoing authentication flow is pretty seamless for the end user. The user's authentication device is going to sign a challenge issued by the relying party server, and then the server can validate the signatures with the public key and approve the authenticated transaction. Let's take a quick look at how that works. I'm back over in WebAuthn.io. I think this demo website saves credentials for 24 hours, so I can log into this site at any point in the next 24 hours after I had initially registered the device. And so I'll just have to click login here using the username that I created. It's going to go through the same process that it kind of prompted me for before, except for it's not going to let me choose what type of authenticator that I want to use. And so for this one, it's going to prompt me to use Touch ID or enter my system password again, and then that's it. I'm logged in, and that's because it's a very simple and very fast method of authentication. It uses the method that we kind of just talked about of signing the credential in order to send that over to the server and to the relying party, and it's pretty straightforward. And I think that's one of the reasons that people are so excited about this, is it's a pretty cool method of authentication. Let's talk about why people are so excited about this. I think WebAuthn is finally a promising solution towards decreasing passwords as a form of authentication. And with platform authenticators, the authenticators built into the devices that we already have, users won't have to jump through a lot of hoops, so there's hope for adoption. Another huge advantage of WebAuthn is that credentials are tied to a specific domain, making WebAuthn phishing resistant. Even if you register or sign a lookalike authentication request, it won't actually work to get to the, intended or targeted site. So phishing protection is a huge benefit of WebAuthn. And I also like this call out from Yubico, who make the YubiKey, that it's no longer as lucrative to hack a database containing authentication information because the information in the database is essentially useless since it's only half the equation. And assuming that the credential is implementing the public key cryptography, right, you can't back out a private key when you only have a public key. And we can't forget speed. Tapping a button or looking at a screen is going to be so much faster than writing a password or even, a 4 to 6 digit one-time passcode that you might have sent to your phone. In fact, a 2019 study on the usability of different authentication factors found that U2F had the fastest median authentication time. And according to Duo's research from the same year, it could save a user almost 20 minutes annually compared to SMS. But of course, it's not without challenges and obstacles. So let's take a look at some of the things that might be challenging as we're implementing WebAuthn in the next couple of years. The obvious hurdle here is technical capabilities. It's been a few years since it's been released, but WebAuthn isn't supported by all browsers yet. It's getting close. We're up to 87.39% the last time I checked. A big one that doesn't support it yet is Chrome on iOS. There's something that's missing there, but I think it's coming soon. And this is a big part of why we haven't seen a lot of adoption to date, but hopefully this won't be a huge problem for long. Another obstacle that we are going to see is getting authenticators into the hands of users. SMS remains a really popular choice for two-factor authentication because most people can receive text messages and they don't have to do anything to enable that. If you start to look at things like roaming authenticators, YubiKeys, they cost like $50, and that might be okay if you're an IT department buying these in bulk and maybe getting a discount and like the end user isn't actually the one paying for this. But most people aren't going to buy these for themselves for consumer identity use cases. So I think that we really have to look to platform authenticators as the future here, the authenticators that are built into the devices that we already have. But I did a very non-scientific study on this, and even among my tech-heavy followers on Twitter, 40% of them wouldn't be able to use a WebAuthn implementation with a platform authenticator. So this is something that we have to consider. It's not going to be a perfect solution right away. We're still going to have to offer other options for a while. And you can actually see this for yourself if you go to twill.io/WebAuthn. I built a small site so that you can test if your browser and your device that you're looking at it on would work with WebAuthn and a platform authenticator. This might be something that you already know based on whether your device has something like Touch ID on it, but it can show you how that works and whether or not it has support for it. And I can quickly show you what that's doing under the hood and how the browser API works a little bit. So I'm over just in the browser console on Chrome that I'm going to write a little bit of JavaScript in. You kind of have to test this within the browser itself because it's a browser API, and so this is the best way to write a script to test this. And there's a couple of things that we want to check for here to see if we have compatibility. The first is whether or not the browser actually supports WebAuthn, and that's a method that's available on the window object called public key credential. If this exists, which you can see here that it does, this doesn't return undefined, that means that the browser supports WebAuthn. So cool, we're halfway there. Our browser supports WebAuthn. This is the thing where we saw that there was 87% compatibility, so there's a good chance that, especially if you're running Chrome on a desktop or Safari or a major web browser on a desktop, you're probably going to have support at this level. But the next thing that I want to check for is whether or not there's support for platform authenticators. And handily, there's this method available on the public key credential object called is user verifying platform authenticator available. So that's a handful, or a mouthful rather. And what this does is it returns a promise of a Boolean about whether or not the authenticator is available. So we do have to write like a little bit of JavaScript to get access to this promise. And so we can say if this is available, then what we're going to do is test whether or not the Boolean is true or false. If I can spell. So we can go ahead and log that this is supported, PA available. And then otherwise, we can assume that there's not a platform authenticator available. And so in that case, we would say, you know, there's no platform authenticator found. And so that's hopefully a pretty easy way to test for platform authenticator support. Oh no. Let's go ahead and try that again before I hit enter. And so that's a cool way of testing in your own browser whether or not that's supported. And I wrote a little script that can do this that I'll link to in my GitHub if you want to check this out later. It's interesting because Okta's own data shows the small percentage of WebAuthn deployments. And I asked Randall over at Okta why he thought this was, and he said it's because there isn't wide support for WebAuthn across different websites yet. And that makes sense. There's a couple of market leaders, like I know GitHub and Cloudflare have implemented this for their consumer applications. They've built the support for WebAuthn, or at least U2F, but there's not as many consumer applications that have this option yet. And part of that might be tied to the fact that this is new technology. And with new technology, there's a lot of best practices. There's not as many best practices or documentation floating around, right? And this is something that also involves cryptography. And even though I have a decent amount of coding experience, like I'm not a mathematician, I'm not a cryptologist. And so like, cryptologist. I'm not a cryptographer. And so I look at this kind of stuff and I cringe when I see this because I don't know what this is doing under the hood always. And this is Python's library for cryptography. And this hazmat extension or area of the library is really funny because when you look at the documentation for it, it says like, here be dragons, don't use this unless you know what you're doing. And that's fine, right? Like this stuff should be inside of libraries, but there's nascent library support right now and not as great of documentation for all of these use cases. So it's going to be something that your average developer might struggle with implementing out of the box. So as a community, one thing that we can do is help shore up the library ecosystem and write more tutorials for this kind of thing. That kind of community support can really help move more implementations forward too. And while user experience applies to all types of authentication, it's especially important for something new like WebAuthn. A 2018 study that focused on the usability of YubiKeys found that setup success varied a lot depending on the site that it was implemented on. So on Google, users had 83% success of setting it up, compared to Facebook, where they only had 32% of success. And a lot has changed since 2018, right? But it is an interesting look at how onboarding user experience impacts user success. You might notice that more people actually locked themselves out of Windows logon authorization tool than successfully set up the authenticator. And despite being the fastest authenticator, U2F had one of the lowest scores for usability. In this 2019 study, the researchers noted this inverse relationship that faster authentication does not necessarily mean higher usability. And this isn't necessarily the perfect study for WebAuthn since it's specifically looking at a second factor, and that was in addition to passwords, but it does indicate that it's not a flawless solution. And finally, there's all sorts of other edge cases that we have to consider. All of this might seem like a lot. There's a lot of obstacles that we have to get through here, but I wanted to be realistic about some of the challenges that we have to overcome in order to make WebAuthn successful, because I want WebAuthn to be successful. I think if you're like me, you don't want to have people using passwords forever. So I'm not going to dive into implementation details, but I do want to point you to a couple of really good resources for getting started. Duo put together a really great overview that you can find at webauthn.guide. It links to the demo that I showed and includes some links to existing libraries that you can use if you are going to be implementing this and implementing servers and that kind of thing. And if you prefer a hands-on approach, I really like this code lab from Google that provides a step-by-step tutorial on how to implement WebAuthn. It also skips over building the server, but you probably will use a library for that part anyway, so it's fine. It teaches you a lot about how the relationship works between the browser and the server and between a device. And to wrap up, I wanted to walk through a few additional considerations around best practices for implementation. And a lot of this has to do with account recovery and fallback options. So think about what happens when somebody swallows their YubiKey, right? Or more likely just loses their authenticator or their device, changes phones, etc. Like this stuff is going to happen. The downside of being tied to a device is that people are going to lose things. But another good point is that some authenticators require biometrics to activate, and so you have to consider that use case too, right? Like if you're going to be requiring that somebody uses their fingerprint, fingers can get wet and that can mess up the way that the reader works. Faces now have masks on them half the time, so you have to make sure that you have a fallback option, maybe to something like a PIN. And one of the great things about WebAuthn is that people can register multiple authenticators and use them as a fallback. So you probably wouldn't have somebody set like 2 passwords for a site, though that does happen. But you can have people register multiple types of roaming or platform authenticators on a given device or for a given account. And while you never want to force someone to register less secure authentication methods, it's wise to offer other fallback options. TOTP might be a reasonable solution here. Cloudflare does this. A lot of other companies are basically default to using recovery tokens. And so while I still don't have any research to back this up, I do have a hunch that people don't actually save these. So think about your other options, like I mentioned, TOTP, or I know, even SMS. There's a lot of promise here. I think it's a rare unicorn of a usable and secure option, at least for the end user. The challenge is getting folks like us to roll out implementation of WebAuthn to be ready when more people have authenticators on the devices that they already own. In the meantime, we can help each other by sharing what we already know about our implementations and the libraries that we're using and maybe contributing to, and maybe actually we'll see the death of passwords. I hope I've given you some inspiration to get started with WebAuthn. You can find me on Twitter if you have any questions. Once again, my name is Kelley Robinson, and thank you for listening.